And we are live in theory. Welcome everyone to Learn Solus Packaging Session 4. This is an introductory session for learning Solus Packaging, as well as being the first session that is after our migration to diffusion and differential on our dev tracker, which is Fabricator, which changes up the process a bit for submitting patches, but in a good way. It's actually a lot easier, and we'll go over that in this session. But first off, before you actually do any packaging, you actually need to install stuff on your system and prepare it for packaging. So that means we are going to need to install the system.devel component. So let's just dive right in. So for this, you are going to need to do sudo eopackage install -c, which means component, and then system.devel, which is the development some of the development libraries and tools and stuff like Meson. The next thing you're going to need to do, because I already have that installed, you're going to need git sol build arcanist and sol build config unstable, and we'll get into that in a moment. And as you can see, I already have all those things installed. So the sol build config unstable is a configuration file that allows you to utilize the unstable profile, which means you will be compiling against the unstable repository by default. Now, if you are running the main repository, which is like the stable repository, then you could also just pass the -p flag when you're building, do -p main-x8664, and that will build against the stable repository. And this way you can build a piece of software and test it if you do not feel like running the unstable repo. So next thing we are going to need to do is do sudo sol build init. And it's just going to say ... single quotes has already been initialized, which means we already initialized our image. But in most instances, what this is going to do is it's going to pull down the unstable image for you. So that being said, if there is ever packages which are updated that are in system.devel or system base or are included in the sol build image, these are packages you are going to need to maintain and update in your sol build image. And you could do that by running sudo sol build update. So it updates the repositories and it pulls down any packages. And as you can see, it says some of these packages are already installed and not going to be installed again, like IP route 2 and file devel and nano and nasm and all that stuff. So our sol build image is fully up to date. So the next thing we are going to need to do is create a folder that will contain the common repository, which is what will have some of the tooling that we'll be using, the Symlinks for that, and then any of the subfolders for any of the packages we're going to be doing, such as Budgie Haste Applet, which we'll be getting into in a moment as our example. I already have a repository-stream folder set up, but I would recommend maybe setting up just a repository folder. And then next thing we are going to need to do is we are going to need to head over to our Fabricator, which is dev.solus-project.com, and use the search box up here and type common. And as you can see, it pulls up this rcommon, which is a repository, and copy paste the address for the HTTPS Git repo here. And you will want to do a git clone with that address right there. Now, I already have it cloned, so I don't have to worry about that. But the thing we are going to need to do now is apply some symlinks in this directory that are that are symlinks to contents within the common folder. And you can actually find these on our building a package article here. And you can find it on our help center. Just click help and then type building a package and it will drop you to this page. And here you can see the 3 lines that we need to run. So that is all set up. And next thing we are going to need to do is configure Git. So the first thing is we are going to need to be setting our name globally. So I just put it as your name here. And you are also going to need to set your user.email to your email. So you would do this through git config global user.email and then your email address. And the next thing we are going to need to do is set up the packager file in the .solus folder in your home directory. So we're going to want to do makedir -p and then the tilde symbol, which means your home directory /.solus. And you are going to want to do nano.solus /packager. Now, as you can see, I already have it filled out. Now, what this is basically a short INI file. So you have packager state up here, and you have 2 key values. You have name and you have email. And if you want this content, it's actually up here in the setting up packager file, where you have packager, name, and email. So just write that out. Next thing we are going to need to do is set up Arcanist, which is a tool that is used for creating patches and submitting them, landing them, and so on, as well as some manipulation of tasks. So what we are going to need to do for that is we are going to go over to the submitting the package article here. We are going to go down to the setting up Arcanist section, and it states to install Arcanist, and then you are going to want to run arc set config default, and then to that dev stuff, to the dev address, like so. And then you are going to want to do is arc install -certificate. Now I'm not going to run this because it will provide you a unique URL, and this URL is what you would use to log into Fabricator, our dev tracker, and you will receive a unique conduit API token, and this token is what is used to grant Arcanist on your machine with access to Fabricator. So now you'll be all done setting up your system. And it is time to actually do a short package. So what we are going to do is use budgie haste applet as an example here. So we're going to want to create a directory called budgie-haste-applet. So here we are, and we are going to want to git init this repo. And the next thing we're going to want to do is create a makefile that includes the makefile.common from the repository folder. And we could do that with echo and then in quotes include /makefile.common, and that goes to the makefile. And you could actually get this in, I believe, building a package. Yep, right here. It has the information. So the next thing we are going to need to do is go and get the tarball. So this will be under the releases section. And as you can see, we have 0.2.9, which was 8 days ago. So that's the latest release. We are going to want to right click and do source code and copy the address for that. Now I have a bash alias set up called fetch YAML. Now this is actually set up in the packaging practices. So if you go over to our help center and you type in packaging practices and go to generating a package.yaml, you'll see we have a recommended alias for actually generating the package.yaml. Alternatively, what you can do is do /common/scripts/y.py, and that is just basically a reference to fetch YAML. And then you pass the address of the tarball. Now, it's worth keeping in mind this doesn't necessarily have to be a tarball. It could be a zip file, for instance, as well. So it fetches it and it generates a package.yaml. And as you can see here, we need to set up the name, the version, the release. So the release always starts at 1 and it's independent of the version. And we always increment that by 1. So we always add 1 to it whenever we do a change. We need to update the license, component, basically the group that the package is in, the summary, the description, and then we have build dependencies, and we have the setup, build, and install steps. So we are going to add the budgie haste applet in the name. We are going to remove the V from that version, and we are going to go get the licensing information. So that is under the license file, and as you can see, it states GNU GPL v2, which is actually the default. So we are going to remove the check me bit there. Now the next thing we need to do is figure out the component. So how do we do that? What you could do is run eopackage-lc, which is a shortcut for eopackage list-components. And as you can see, we have a bunch of them. And we are going to choose desktop.budgie because it is a budgie applet. Next, we are going to copy paste this summary up here. And that will end up being our summary and our description. And now we actually need to get the build dependencies. Now, Cyber's a cool guy. He actually lists all the package configs out here, but we are going to walk through getting them anyways. So for this, it states that we need budgie-1.0, and it says on Solus, this could be, you could get this by doing budgie-desktop-devel. So let's go ahead and do that. So what we are going to need to do is eopackage info, so we're getting the information about the package. budgie-desktop-devel. So the devel packages are basically sub-packages that contain the development files for a particular package. So these are all the development files for Budgie Desktop. Now, as you can see, it has this provide section here. Now, this provide section specifies package configs for us to use, and we should always use package configs whenever possible. But something that's worth noting, under the dependencies section, is it lists libgtk-3-devel, and if you go back here, it specifies the dependency. One of the dependencies is GTK, the GTK3 package config. So we don't actually need to get the package config for GTK3. All we need is the one for Budgie, because Budgie at this moment in time is based on GTK. Next, we are going to need JSON glib-1.0. So let's go ahead and do a search. So we did EO package search JSON-glib, and it pulled up the lib JSON-glib package, as well as the devel sub package. And we are going to do EO package info on that devel sub package. And as you can see here, it pulls up that package config, so we are going to copy paste that. Next, we are going to need libsoup-2.4. So we are going to do a search for libsoup, and it pulled up the packages here. So for libsoup, we have the devel sub package. And we have the package config for it here. And next, we are going to need Vala, which is just the package Vala. Now, our script tried to get the appropriate macros for this, but it didn't. So it says from installing from source, we are going to need meson ninja, and we are going to need to do the sudo ninja install. Now, lucky for us, we have actionable macros. So what are actionable macros? Basically, they're shorthand ways of performing an action, and it allows our packages to maintain some consistency, such as setting prefix or libdir or particular executors or builders, and automatically creating those. And we actually have actionable macros for meson. So if we go over to the macros section and click meson actionable macros, you can see we have one for meson configure, meson build, and meson install. So what the meson configure does is it uses our C flags and libdir, and for build, it actually runs ninja and passes our jobs variable. So basically, the jobs variable typically is set to the same amount, or it's set to the equivalent of how many cores you have. So it can indicate how many builds we should be doing concurrently. And then meson install will actually pass the appropriate destination directory and the jobs variable. And we'll get into all these actionable macros and a lot of the variables in session 4.1. This is just an introductory session, so just to dip your toes in the water, and if you're interested, obviously you could go and learn more. But let's go ahead and modify these setup, build, and install steps to actually have the meson actionable macros. So there we go. Now let's go ahead and build this. And we do that just by typing make, which is actually more or less a recipe that calls sudo sol build package.yaml. Let's go higher up in the buffer. -p, so we're passing that profile here, unstable-x8664. So what it's doing right now is it's pulling down all the dependencies we need. Fortunately, I have all them cached locally on my system. And it installs them into essentially the image that we are going to be using during the build. And it's done. It's not a complex one, that's for sure. So if we do ls, you can see we now have a EO package file. Now it's always worth double checking the contents of the EO package to make sure there isn't anything that shouldn't be there, or if you are doing if you're creating a package that's a library and it creates a devel subpackage, it's worth checking that there are no .a files or static libraries in there as well. So as you can see, our Budgie Haste applet package is completely normal. It has a .plugin file, a shared object, it has some XML files for the app data and the G schemas, it has some locale information, and that's really about it. It's really all it needs. So we are going to run make clean just to clean it all up. And now what we are going to do is we are going to learn how to submit the package. So we are going to create a git commit. So we are going to add the make file, the ABI file, so the ABI use the libs file, the package.yaml, and the pspec file. Next, we are going to run git commit. And assuming I could type it all out correctly, what you would see is initial commit of budgie-haste-applet. So now if we check, you could see under git log, we now have the initial commit there. So how do we create a patch? Well, it's actually really simple. We just do arcdiff. And as you can see, it adds our commit message there. We add a summary. So in this instance, it's just going to be the same. And we are going to intentionally mess up on the test plan. So essentially the test plan is how did you and how should other individuals test this package? And this is really important if you're, say, doing an update on an existing package and maybe there is some changes to it. It's important to actually test those. So I'm just putting in my test plan intentionally mess up and not provide a test plan. And what we are going to do is leave the reviewers and subscribers blank. These will get automatically updated with the triage team and stuff. So we are now going to save this out. And it did all the magic for us, as you can see. So it actually gave us a differential revision URL. So we're going to copy paste that. And as you can see, it has the initial commit and stuff here. Now, oh no, I realized I messed up on the test plan. Who would have thought? So now we actually need to go in and fix that. So what we are going to want to do is run arcdiff -edit. and we are going to want to change that test plan. And I changed, of course, to tested on Budgie because it is amazing, which is a bit ironic because I'm running GNOME Shell. And it's going to open up a secondary editor session, and we are going to just have initial commit of Budgie haste applet there again. And if we refresh, you can see it did the tested on Budgie because it's amazing. And that's really it. We already went through, we added the appropriate makefiles and ABI libs and the package.yaml and the pspec. Now the only right thing for me to do at this point is to kill this patch off because it's my own and it's a test one. So I'm going to abandon that. And that's really it. That's as complicated as it gets in terms of the initial setup and the initial submitting of a patch. And in our next session, which is session 4-1, we're actually going to be going over a bunch of macros because we actually have a lot of them. Because we have some for the GNU build system. We have some for CMake. We have some for Haskell. And of course Meson, which you already saw. Perl, Python, and Qt. And then of course we have variable macros and variables themselves, which we'll get into, such as workdir, installdir, package files, which is used for the files directory and any additional files that we want to provide, and of course sources. So thank you for tuning in, and I will see you next time.